Bless you. All right, so last class we were on the unit circle, and we had, bless you, found the degrees all the way around the unit circle. We converted the degrees to radians. Remember, a radian is if you take the length of a radius and lay it on the arc of the circle, how many radii would like this arc be? Okay, so this arc is pi/6 of an arc. A whole pi would be a semicircle. Okay, so this is 1/6. This is 1/6 of a semicircle in radians. All right, so we talked about that, and then we started finding the ordered pairs of each one of these. And remember, the ordered pair, the x is your cosine of the angle, and the y value is the sine of your angle. So we were working our way around, and we got to 150 degrees. That's where we left off. Okay, so we are on page 203. And again, once we finish the circle, I'm going to give you a blank unit circle and take your notes away, and you're going to have to complete the whole unit circle on your own without notes, only the formulas that I give you. So make sure you're paying attention. Okay, so we are doing the 150 degree angle. So from here, we go in a counterwise clock rotation, that's 150 degrees. We know we went counterclockwise because it was positive, right? If you go clockwise, it's negative rotation. So a right angle, which we use right angles to help us in trigonometry find these angle measures. Can you have 150 degrees in a right triangle?
Yes.
No. How many degrees is in a triangle altogether? In the whole triangle? 180. Well, if you know to have a right triangle, that's 90 degrees, right? Well, if you have a 90 degree angle and a 150 degree angle, is that even possible? Because you still have to have a third angle, and you've already gone over 180 degrees. So we can't use this side of the angle to help us find what this point is right here. So that's why we use the other side of the angle to help us. We just go to the point where it intersects the circle and draw a line straight down, and that forms a 90 degree angle. Okay? So if it was 150 degrees from here to here, then how many degrees do we have left before we hit that semicircle? 30 degrees, right? Because isn't there 180 degrees in a straight line? Yeah, so if this is 150, you got 30 degrees left before we get to that semicircle line. So to find this point, we're going to be finding the cosine and sine of the 30 degree angle. So we're finding cosine of 30 degrees, and we're finding the sine of 30 degrees. So remember yesterday we talked about SOHCAHTOA, or yet whatever day. Remember, I say SOHCA, you say TOA. So cosine, that's the K part. Cosine, what did the A and H stand for? Adjacent over hypotenuse. So we need to have the adjacent side and divide it by the hypotenuse. So in a 30, 60, 90 degree triangle, remember your smallest leg we call X or S, whatever, and your smallest leg is directly across from the smallest angle. I'll call it X since I've been calling it X. The hypotenuse is twice as long as the smallest side, and the hypotenuse is directly across from the 90 degree angle, right? And then the middle side is directly across from the 60 degree angle, and that's the small side times the square root of 3. So we just take those relationships, plug them in, simplify, and there's our answer. So here's our 30 degree angle, that's our theta. Which one of these side lengths would be considered adjacent to the 30-degree angle? X square root 3. And the hypotenuse is 2x. Can I cancel those x's out?
No.
I actually can because they're not under the radical, and these are both monomials. So I can cancel those out, and I get the square root of 3 over 2. Can I have a radical in the numerator? Yes. It's just the denominator that you can't. Okay. Remember, when you are in, they're all going to come out positive. But on the unit circle, everything's not positive. If you're in the second quadrant, are these x values positive or negative? Negative. So your cosine, that's your x value, okay? That's going to be negative square root of 3 over 2. So that's our x value of the angle. So let's find the sine of 30 degrees. So sine is the so part. So that's opposite over hypotenuse. So what leg is opposite the 30-degree angle? X. Over the hypotenuse is 2x. Simplify and you get 1/2. Remember, sine is your y value. Are the y values positive or negative in this quadrant? Positive. So we'll flip back over and we'll fill this in. Negative square root of 3 over 2, comma 1/2. Everybody cool with that? And remember the ordered pairs, the like at 0 degrees, 90, 180, 270, and back at 360. Those ordered pairs are easy to find because the length of the radius is at 1. So those ordered pairs are easy. We don't have to do all that math to find those. Okay, now we're going below that 180 mark. So we'll go down to 210 degrees. And I still have room on this page. So I'll kind of speed it up from here. Just want to kind of jog your memory. So from here to here, that's 210 degrees. So we know it's 90 degrees from here to here, 180 degrees from here to here. So how many more degrees is it from the 180 mark to the 210 mark? What is it? 30 degrees, right? So now when we draw that right angle, now we're going to be drawing it in this direction. We always draw it towards that semicircle line. So the smallest leg we call x. The hypotenuse is twice as long as the smallest leg. And that middle length is x square root 3. So we're finding the cosine of 30 and the sine of 30. Cosine adjacent over hypotenuse. So adjacent would be what? X square root of 3 over the hypotenuse is 2x. So that reduces to the square root of 3 over 2. X values in this quadrant, are they positive or negative? Negative, so that's negative square root of 3 over 2. Sine of 30 is opposite over hypotenuse. So opposite of the 30-degree angle is x, hypotenuse is 2x, that reduces to 1/2. Are the y values in this quadrant positive or negative? Negative. So flip back over. And we'll go to 225. Now remember, when I get this to do on your own, you're going to have to do all the degrees as well. Remember, everything is, it's 30 degrees, and then it skips 15, 15, 30. 30, 15, 15, 30. 30, 15, 15, 30, right? So you just got to go and add, you're either adding 30 degrees or 15 degrees each time. 30, 15, 15, 30. Because I'm not going to give that to you. You got to do the degrees as well. And then the radians, degrees to radians, you got to do that too for every single one of them, just like we did here. So you got to go back and use that formula and you got to reduce all the way. Okay, so now we're up to what, 225 degrees? And this is page 204. So if it's 180 degrees from here to here, how many degrees is it going to be from here to here? How many is it? So 225 minus 180, 45 degrees, right? So this is a 45-degree angle. If you're just talking about right here, we'll make a right triangle. The smallest side is X, and we have two of those because in a 45, 45, 90, the two legs are equal to each other. And a hypotenuse is the smallest side times the square root of 2. And we're looking for the cosine and the sine. You can't do that backwards. Sine comma cosine is not going to work, okay? Cosine is your X, sine is your Y. So we're finding the cosine of 45 degrees and the sine of 45 degrees. Cosine is adjacent over hypotenuse. What is adjacent to my 45-degree angle? X. What's the hypotenuse? X square root 2. Can you leave a radical in the denominator? No. So we have to rationalize the denominator. That means we're going to multiply by 1, but instead of 1, we're going to do square root of 2 over the square root of 2 because that's going to help us get rid of this denominator. If that was the square root of 3, we would multiply by the square root of 3 over the square root of 3. Have y'all rationalized before? Hopefully. So my numerator, x times the square root of 2, is x square root 2. And the denominator, x times the square root of 2, that would be x square root 4. Do my x's cancel? Yeah, because x divided by x is 1. Square root of 2, I'll leave as square root of 2. What's the square root of 4? 2. So that made my radical go away. Can I cancel out those 2's? I can? No, because the square root of 2 has a different value than the number 2, right? Square root of 2 means 1.41421356.2. Does that cancel with the number 2? No. Whoops, I can't see that. You get it though. So is that going to be negative or positive? What's the x values in this quadrant? Negative. So sine of the 45-degree angle. Sine is opposite over hypotenuse. So opposite of the 45-degree angle is x over x square root 2. Exact same thing as it was before. Notice when we have the 45-degree angle, that always happens, right? You're going to get the same thing. You just really have to pay attention to the signs. So we know the end result is square root of 2 over 2. And all of the y values in quadrant 3 are negative. So that x and y value, or cosine and sine, are identical. Is this making sense? Okay, what do we have next? 240? And to me, it's easiest to draw that circle every time. You may think it's a waste of time. Maybe it is for you, but for me, I have to visualize what it is that I'm doing. So here to here is 240 degrees. You definitely can't have a triangle with 240 degrees in it. So if we make this into a right triangle, how many degrees is it from here to here? 60. So that means this is 30. So this time, my smallest side is over here. So that's your x, or if you want to use s, that's fine. Hypotenuse is twice the length of the smallest side. And the middle side is the smallest side times the square root of 3. Now, I'm going to give you these ratios on your test, but when y'all get to pre-calc, they're not giving you that. You have to memorize all this stuff, okay? All right, so what are we doing? Cosine of 60 degrees and sine of 60 degrees. So cosine, adjacent over hypotenuse. What is adjacent to the 60-degree angle? X. Why is it not 2x? That's a hypotenuse. And the hypotenuse, yes, it's adjacent to that angle, technically, but you can't use it as the hypotenuse and the adjacent leg. It can only be the hypotenuse, okay? So the hypotenuse is 2x, so what would that reduce to? Negative 1/2. So it's not negative there, but it's negative on the unit circle. Because here you're talking about a distance, right? And distance can't be negative. But when you're talking about where it is here on the unit circle, you're talking about an x value, and that's negative. Okay, sine is opposite over hypotenuse. So what leg is opposite of 60? X squared root of 3 over hypotenuse is 2x. X's cancel. They're both outside of the radical, and they're monomials. So square root of 3 over 2. You can have a radical in the numerator, and that y value is negative. I wrote that in a weird place, but it's supposed to be there. All right, we already have ordered pair for 270 degrees. Does everybody understand why it's 0, negative 1? Has an x value of 0. If this length is 1 unit, then this is negative 1 right here. Okay, so now we just have 3 more to do, and then I will cut you loose to do the whole thing by yourself. So we are at 300 degrees. Maybe write smaller, try to fit it all on this one page. So here to here is 300. We know from here to here is 270 degrees. So how far is it from this point to here? How big is that angle? 30. But if I draw it like, if I do this here, am I going to be able, I'm going to draw my triangle this way, correct? So this 30 degrees is not what I'm going to be able to use when it's on this side. So how many degrees would it be right here? 60. So I'll have to use that 60-degree angle, even though I'm finding this ordered pair. No matter which one I use, I'm going to get the same place. But from where this stands, you don't draw a 90-degree angle to your y-axis. You have to draw it to your x-axis. Okay, so a little bit confusing when you get on that side. So we are finding cosine and sine of the 60-degree angle. So this is the 30-degree. So remember, the smallest side is x. The hypotenuse is 2x. And the middle leg is x square root 3. So cosine is adjacent over hypotenuse. And adjacent would be x. And the hypotenuse is 2x, so we know that's 1/2. And that's your x value. Is that positive or negative? Positive. And the sine is opposite over hypotenuse. So sine opposite is x square root 3 over hypotenuse is 2x. So square root of 3 over 2. Now your sine in this quadrant, that's your y values. Is that positive or negative? Negative. And make sure the negative sign does not go under the radical, it goes outside of the radical. Everybody cool with that? Okay, two more. 315. Don't know if I'm going to be able to get it all on this page. So if it's, we know we're going to have to draw the triangle this way, right? So if it's 315 degrees from here to here, how much do we have left before we hit the 360 degree mark? Wouldn't it be 360 minus 315? So that has to be a 45 degree angle right there. And this would be a 45 degree angle too, correct? Correct. So your legs are the two small sides, and then of course your hypotenuse is x square root 2. I know that's tiny, but I know y'all know this stuff by now too. So we are finding the cosine and sine of 45 degrees this time. Cosine, adjacent over hypotenuse. Adjacent would be x over x square root 2. We've already done the math on that, and we know it's the square root of 2 over 2. And the x's are positive over here in quadrant 4. Sine is opposite over hypotenuse. Opposite is x, hypotenuse is x square root 2, and again, we know that is square root of 2 over 2. Our y values, or our sine, is going to be negative in quadrant 4. Fill that in real quick. Last one. 330 degrees. So you notice how we're getting the same numbers. There's a pattern that goes all the way around. When you do this on your own though, I want to see each one how you do the math, because that's how you're going to remember it. And then eventually when you memorize it, cool. But for now, I want to see that you know how to do the math on it. All right, I'm going to squeeze 330 degrees over here instead of using a whole page for that. So when I draw my triangle, my right triangle, what's my theta going to be? Meaning what angle that I'm going to use to find cosine and sine? 30 degrees. So this is 60. So my smallest leg is x. The hypotenuse is 2x. And the middle leg is x square root of 3. Cosine of 30 degrees. Cosine is adjacent over hypotenuse. Adjacent is x squared root of 3, and the hypotenuse 2x. The x's cancel and you have square root of 3 over 2. Your cosine's positive in that quadrant because that's your x values. And then your sine. Sine is opposite over hypotenuse. Opposite of theta would be x. Hypotenuse is 2x. And that reduces to 1/2. That ordered pair here, because that's your y value, right? So that's going to be negative. So we have positive square root of 3, comma, negative 1/2 for 330 degrees. Y'all cool with that? Anybody have questions? Say what? Oh, I don't know. I don't know why they have like these extra. I don't know if one of them was for the 0 and then one was for the 360 probably, because 0 degrees is 0 radians. And maybe that's what they wanted over here. 360 degrees is 2 pi. I just wrote it below because I thought it was confusing. But it's all in the same spot. It just depends on, have you made the full rotation yet, or are you still just at 0, 0? Does that make sense? Yes. Oh, okay. Let me just pause this, and then you can borrow this if you need to. Any other questions?